Hello everyone, this video is regarding lab assignment 9 machine learning deep learning of EE542 internet and cloud computing at USC. My teammates are Aswathi and Dhrumil and myself Prem Kumar. The goals of this experiment is generating scatter plots of the given features, then selecting a suitable machine learning algorithm and report the training efficiency, test accuracy and the test F-score. Then we implement the same machine learning task on Amazon SageMaker. Then the required tasks are performed using a deep learning machine AMI for the banknote authentication dataset.
The first step for this experiment is to create a notebook instance, and we do that using Amazon SageMaker. So let us see the procedure for how to create a notebook instance. Click on this. Here we can give the instance name as lab9 note for this particular experiment and select the instance type to be mlm4.xlarge. And before starting the experiment, it is very important to specify one IAM role. So let us keep it as create a new role, any S3 bucket, and create role. Keep all other values at default and just click on create notebook instance. Now, once the status of the instance changes to in service, we can open the instance. It will redirect us to Jupyter, and here we can start coding.
The homepage of the Jupyter notebook where we can code for our machine learning algorithm. So for our machine learning algorithm, we are going to use the inbuilt, and here are the frameworks what we can use from. So we are going to use Conda Python 3. We have already have written a code, so I'll just go through that. So over here, the first step is to import the libraries, different libraries for the Python like NumPy, Pandas, Matplotlib, and also the containers where what we are going to use for our experiment. So I'll just run through that. So as you can see, we got the output as success. So the initial step is done. Now we are going to create a bucket from here, and no, we are not going to create a bucket manually. We are going to create using the code. So let's do that. So the S3 bucket is created. It goes by the name lab9pda1. To download our dataset, the 1372 instances what we are going to use to train and test our machine learning algorithm. So we are not going to upload it to a bucket manually, but we are using the code. So we are going to run the code. So as you can see, it's downloaded and loaded into data frame. Similarly, we are gonna do that for the train and test data. So we have split it the data instances into two parts, 400 for train data and the rest 972 for the test data. So as you can see, you get the success output. Now this is the piece of code what we have written to implement the scatter plot. So as you see, when you run it, you get the scatter plot. So there are 6 scatter plots. So it's the combinations of the 4 features what we have: the skewness, kurtosis, entropy, and variance. So this is for the skewness versus the kurtosis. This is for the skewness versus the variance. This is for the skewness versus the entropy. This one goes for kurtosis versus the variance, the kurtosis versus the entropy, and the last one is for the variance versus the entropy. Now after scatter plot, we need to train our data. So this is the piece of code to train our data. So we are going to run that. The training is complete. Now the next step is to implement the machine learning algorithm for training. And now finally we will train our machine learning algorithm. So this piece of code takes a lot of time because we have 1000 iterations and 400 data sets. So it will take a lot of time. So as you can see, it's starting the training job over here, and it will take a lot of time for that. And at the end, it will say successfully job completed. Now the ML instances have been launched. Training job has been completed, and now we can test our machine learning algorithm. So These are not the errors. These are the 1000 iterations for the 400 data instances what we have used. So after that, we can just implement our machine learning algorithm using the this piece of code. Over here, we are using the instance type as ml.m4.xlarge, which are the instance used for the machine learning algorithm. So after this, we need to remove the label from the fifth column in order to test the data, because for testing, we cannot have any inputs which is not a numerical value. So now we'll run this piece of code where we check what is the number of instances used for training. So it's 400, which is right. Now we'll check the train accuracy. So this is the code for that. So the train accuracy we get is as 100%, and because we get the 100 as the 200 genuine and 200 false. And now we'll do the same thing for removing the label for the so that we don't get any errors. So we'll run this piece of code, and now we are getting 972, which is the number of test instances, and this is to test for the test accuracy, which we get as 99.1%, and the F1 score is 98.91. So this was the testing of our machine learning algorithm. We used an inbuilt. We can also use our customized one like KNN or K-means, but it was very easy, and it helped a lot to understand how machine learning algorithm works using an inbuilt one. Now we need to end and delete our resources in order no extra charges are charged to our account. So this is the code for that, and so the resources have been ended. So the machine learning algorithm study has been done using the inbuilt one and Conda Python P36 libraries and using Python language.
Now we shall start with the deep learning part. So the first thing that I need to do is create an EC2 instance. So I need to launch an instance. I select deep learning, AMI, and then enter. I select this Amazon Linux version of it, then review and launch, then launch. Then here I need to create a key pair. So I said it, create a new key pair, then I give a random name, download key pair. As you can see, the new instance has been created and it is running. Now I open a terminal. Here you can see that I am into downloads. So first thing that I do is change the mod of the PEM file. Then SSH. So for this I need to change this particular thing. I go back here, select this, I copy this, copy and then paste it over here. Then the next thing that I need to do is change the name of the PEM file. It's Kumar P. Enter, type S. So now it's ready. Then the next thing that I need to do is git clone, recursive, github.com/dmlc/xgboost. So the process is running. it's done. So I cd into the XG boost. Okay, now I make it takes some time. Yeah, now the process has been done, and the next thing that we need to do is cd python package, then sudo python setup .py install. So the installation process is going on and it's almost done. Yeah, it's done now. Now I write Jupyter notebook. So this helps us in opening the Jupyter notebook. As you can see, the Jupyter notebook is created and this is the link to access it. I copy this link, I go to Chrome or any other browser, paste the link and then enter. The Jupyter notebook is open and we can always access it now.
So the URL what we got on the terminal, so and opening that on the web browser, this is the home page of the Prem notebook. So now we can create our own experiment for deep learning algorithm using the given frameworks. So we are going to use the framework for Conda TensorFlow P36, which has libraries for Python. So we have already created one. I'll just go through the code. So this is the one. Over here, the basics. Over here, we have not used the inbuilt algorithm. We have coded our own algorithm. So we start with the basics. So now first we'll import the libraries, same the NumPy, Pandas, Matplotlib. So that is done. The second step is to download the data from the site in order to train and test our algorithm. So we run the code. So as you see, we get success. The text file has been downloaded and also loaded into data frames. The third step is to divide the data into forged and genuine based on the labels. So that is the thing. And over here, we are giving the name of the columns as QNS, kurtosis, entropy, variance, and label. So I'll run that. This step is also completed. Now we need to divide the data into test data and train data. So the train data has 400, 200 of the forged and 200 of genuine, and the rest is for the test data. So we'll run that. So this code has been executed. Now the next piece of code is to check how many data instances from 1372 we have in each, like for train and test. So once we run that, we get 972 for the test and 400 for the train. And now this step is for labeling the train data and test data to make the label as the axis 1. The second step is to mention the classifier. Over here we are also mentioning certain attributes. The maximum beta is 5, eta which is the learning rate is 0.1, the gamma which is the forgetting factor is 0, and the other child weight which is between the hidden layers is 6, and we are using the binding logistic. So okay, now this piece of code is for the fitting into the train data and text data. This is same as the training what we did in the machine learning thing, and we have kept 1000 instances for 400 train data and 970 test data. Now this is for the predict part. So this is the main algorithm where we get the train accuracy and the test accuracy. Over here we are creating 4 variables as the true positive, true negative, false positive, and false negative. True positive is that we predicted 1 and the actual value is 1. True negative is we predicted 0 and the actual is 0. False positive is we predicted 1 but the output is 0, and false negative is we predicted 1 and the output is 0. And now we calculate train accuracy depending on these 4 variables, and once we run that, we get the train accuracy as 0.99 or 99.7%. Same thing goes for here. The true positive, that is predicted 1, output 1. False positive, predict 0, output 1. True negative, predict 0, output 0. False negative, predict 1, output 0. And same thing we use to calculate the true positive ratio, the true negative ratio, the train, and based on that the accuracy and the precision. So the true positive ratio is true positive upon number of positive, that is true positive plus false positive. True negative is the true negative plus false negative, and we get the precision by true positive upon the true positive plus the false negative, which were actually predicted as the net positives, and so we get the test accuracy. So this is the piece of code. So we get the test accuracy as 99.2%. So the deep learning algorithm has been completed successfully, where we get the train accuracy and the test accuracy.
Now that our entire experiment is complete, we need to terminate all the instances in order to avoid any additional charges. In this lab for machine learning, we have used Conda Python 3, and for deep learning, we have used Conda TensorFlow T36. For machine learning, we use the inbuilt algorithm of SageMaker, but for the deep learning part, we have used the customized built-in algorithm using TensorFlow libraries. The only advantage of using the inbuilt algorithm was to get the train accuracy to be around 100%, or to be exactly 100%. But the test accuracy for both the machine learning and deep learning were mostly the same. In this experiment, we got the train accuracy for machine learning to be 100% and the test accuracy to be 99.18%. And for deep learning, we got the train accuracy to be 99.5% and the test accuracy to be 99%. Thank you for watching this video.